So as you know, already we completed work under types of work and as well as different numericals in our last class. So now in today's class we are going to start the next concept, that is what is all energy. Okay. Then we'll discuss what is the examples of energy and what is the types and what is the formulas and what is the derivations and all. So let us see that now, all of you. So first we are going to study we are going to define what do you mean by energy. So now let us talk about two different people. So basically energy is the common word we will use in our daily life very frequently. So many situations we used to say talk about energy when we are eating food or when we are doing something or when we are running, when we are standing. So always we say, I don't have energy to stand, I don't have energy to read, I don't have energy to do this, that and all. So let us see what is this energy, what we are using in our like regular life, everyday life, very frequent term. So for example, I will take two persons. So let me take, this is a person A, some A, and this is the person B. So we don't know the names also. So basically I says that the person A is more energetic than me. So simply I says that A is more energetic than B. So what does it mean? Anybody can tell? I'm simply saying you statement. I'm having two persons. So compared to B, A is more energetic. So what does it mean? Anybody can tell? So suppose I will give you to clean the gardening work. So now you tell me, who will do the more work, A or B? So I have allotted the task for them
Work very fast.
to gardening work. So not faster if they're working, that is different, Mari. That is power. We'll discuss it in the next concept. That is what after energy, power will come. See, the speed or fastness we'll talk about in fastness of the work. Fastness of the work is power. Okay, Mari? That is different. Clear? So we are talking about now who can do the work. I am not talking about the time. So I have given, for example, gardening work. So now I'm saying you that A is more energetic than B. So according to you, what does it mean? So means in the sense of man A can do more work than B. Am I right, everybody? Yes or no? So what does it mean, everybody? So it means that A can work more than B. So that is the meaning of A is more energetic than B. So what does it mean here? Energy of a body. I am measuring the energy of a body, A or B, based upon the amount of work done. So based upon the amount of work done by a person, I am measuring the energy of a person. So that is why the energy of a body is measured in terms of the amount of work done by the body. Do you all understand what I am saying? So if a body does more work, so means the body has more energy or less energy? Everybody?
More energy.
More energy. So we are measuring the energy of a body, the energy of a system, a given system in terms of doing the work. So how much work they are doing, that amount of work done by a body is actually equals to the amount of energy possessed by the body, or amount of energy consumed by the body. So that is what we will say. So we cannot see this energy, but we can see the effect of energy. That is what, like a force. So we cannot see the force, but we can feel the effect of force. Same way, like here, we cannot see the energy, but we can see the effect of energy in the form of what? Anybody can tell? We can see the effect of energy in the form of what?
Work done.
Work done. That is what is important. So for example, so let me take, I will take one more work. So there is a wooden plank in front of me. Wooden plank. having a thickness of something. So now I have given 2 iron nails to the 2 persons, A and B. So now I have given the same hammer to them, same hammer. Now, if we raise the hammer in air, for example, they have to hit this nail into this wood piece. Now you can see the person A is also doing, a person B is also doing. You can notice it here. All of you observe. If you want to drive this nail into this wooden, so what we have to do it? The person will raise the hammer back. Am I right or wrong? Everybody will raise the hammer in air and allow it to fall on the head of the nail. So he will raise the hammer back and he will come back and he will hit the head of the nail. So the hammer will do the work here in driving the nail into the wood. So the hammer will push this nail or it will do work in driving the nail into the wood. So what does it mean here? If you want to raise the hammer here, the raised hammer is having the what? Energy, which can do the work on the nail. The rising hammer can do the work done in the form of what? By sending the nail into the wood. So who is having the energy here? The rising hammer is possessing the energy. So now, for example, if A is hit this nail, so that complete nail has been went inside. Now this B is hitting that, only small amount of nail is went inside. Now means in the sense of who has done more work, and who has done less work, and who is possessing more energy and who is possessing less energy. Anybody? All of you? A has done more work done because the distance traveled by him is
Yes, because
yes. The nail travel is a longer distance. It's completely inside the wood. It is driven completely into the wood. So complete nail has been driven. But here less amount of nail is driven into the wood. So that the distance traveled by the nail is less. So work done is also less. So who is possessing more energy? The energy possessed by A is greater than energy possessed by a B. So that's why work done by A is also greater than work done by B. So basically, the energy of a body is measured in terms of amount of work done. So that is why whomever having a greater energy, they will do the more work. So based upon this, the energy is defined. If you all notice it, we can define the energy is the capacity or the ability to do the work. Capacity or ability of a body, write it, of a body to do work. So that is what we used to call it as a energy. So now if you take here, the amount of energy possessed by a body. So suppose my body is possessing 100. What is the SI unit of energy, everybody? SI unit of energy. What is that, everyone? Joules. Clear, everyone? So the amount of work done, very, very important statement. The amount of energy possessed by the body, either absorbed or released, both can be possible. So remember that some bodies will release the energy or some bodies will take the absorb the energy, either absorbed energy or released energy. Possessed energy possessed by a body is equal to the amount of work the body can do, amount of work the body can do when energy is released. When energy is released. So that is what we will say. The amount of energy is measured Energy is measured in the terms of what? Everybody. Energy is measured in terms of what, guys? All of you. In terms of what? Amount of work done. That is what we used to call it as a energy, because we won't see the energy. We cannot see the energy. Only we can experience the effect of energy. So energy is equals to work done. The energy consumed by the body or the energy possessed by the body is equals to amount of work done by the body. If a body will release 1 joule of energy, body can do 1 joule of work done. If body can release 100 joules of energy, then the work done by the body is also 100 joules. If body will consume 1000 joules of energy, then the work done by the body is also 1000 joules. So this is what you have to remember. All of you clear, everyone? Yes, please. Yes. So from this you can say, so I will say 1 joule. If I say my body is having 1 joule of energy, means 1 joule of energy is possessed. Suppose if any kind of body possesses, do you all able to understand, Mr. Mari, Pranav?
Yes.
Yes. 1 joule of energy means, in the sense of, it means it has the capacity of doing of how many joules of work done? Everybody. It means it is having a capacity of how many joules of work done? It means the body, yes please. Body has the capacity to do the how many joules of work done? Everybody. Capacity of doing how many joules, guys? 1 joule of, okay. So that is what you have to say that. So that is what we used to say. Joules is the SI unit of energy, and energy cannot be seen, but we can measure the energy possessed by the body or energy absorbed by the body in the form of amount of work done by the body. So that is what you have to remember. Okay, everyone? Anyone having anything doubt, you can ask me, or else we'll proceed. Clear, everybody? Yes? All of you understand, Mr. Prudvi? Prarthana? Solving up? Do it fast. Anybody having anything doubt, you can ask. Understand, Mr. Mukesh, Shivani, Agalya? So I can say the amount of energy possessed by the body is equals to amount of work done by the body. So now you're having a varieties of energies. So of course, that is all not matters for us. So we are not going to study that also. So we're going to study only directly to the kinetic energy. So let us see that and how it will happen. And we are going to discuss one activity for our today's class. So that is only very important activity. So let us make that thing. So directly I'm going to the concept, call it as kinetic energy. So remember, we have many types of energies, but class 9th we are going to study one single kind of energy. That is what we used to call it as a mechanical energy. I'm not going to waste time on this to say all the names on that. Okay, mechanical energy. So mechanical energy is a combination of two energies. One is kinetic energy and another one is potential energy. So now we are going to start with the kinetic energy directly. So what is this kinetic energy? And we'll discuss it everything from what we studied just now. So as I said now, Mr. A and B try to drive the nail into the wooden block. So what is the action done by him? Anybody can tell? What is the action done by them? If you want to drive the nail into the wooden block. So what you have to do it, guys? With the hand you can do it. What they have been done? A and B persons. All of you?
Energy is supplied.
Yes. So there is a nail. I have to drive into that inside. So what they have done, Mari? Others?
With the use of hammer, he
Yeah,
has
with the
possessed
use
it.
of hammer, what they have done? Hammer is simply, I put the hammer above the nail. Is it
Work.
automatically it will?
Work done.
Is it automatically will do? No.
No,
They
sir.
have to raise the hammer. Am I right? They
Yes,
have
sir.
to raise the hammer and then they have to hit. So the moving hammer, only moving hammer can do the work. What the work done by them? It can drive the nail into the wood. So here, if you notice it here, the moving hammer is only possessing the what energy? Everybody? Kinetic energy. So kinetic energy you can represent with a KE or EK, your choice, whatever you are convenient. Now, suppose if I take a football ground, a ball is as a stationary. So now a person who comes and kicks with his leg, now you can see. A player kicks the football as the ball which is at stationary. So what will happen? The ball will start moving. If I kick with my leg, as soon as if I kick it, immediately my ball will start moving. So here, the moving ball has the capacity to do the work. So that will possess the energy. So as it is possessing the energy, then only it can do the work done. So like that, every example you take, the moving car, walking, or running, whomever it is. So all these cases, the person who is in motion, not in state of rest, that is the person is actually possessing the energy. So that energy possessed by the person, the energy possessed by the moving object is called kinetic energy. So that is only we can say a standard definition. Every moving object will possess the kinetic energy. So that's why we'll make a statement that the energy possessed by the body, energy possessed by the body when guys, when it is in stationary or when it is in motion? When it is in motion, by virtue of its motion. So the energy possessed by the body due to its motion is actually we used to call it as a kinetic energy. So that is whatever the moving object, they always will possess the kinetic energy only. The objects or the any kind of living or non-living things which are in a motion, they are possessing the kinetic energy.
Don't doubt, sir.
Yes.
So then, for example, can we take a golf stick?
Yes, the golf stick is moving. Suppose if you take a golf stick, so suppose the ball is at the allotted target. Now you are having a golf stick, whatever you can take it is like it looks like this. Am I right? Correct? So now
Yes,
if you
sir.
have taken the stick, so this moving stick, if you want to hit the ball, suppose I kept the golf stick at near, the ball cannot move. I want to do it what? I have to take the bat back. So that the moving bat having a energy which will drive that ball to forward direction. So if I drive that ball to forward direction, then only that's what the moving bat or the goal stick bat only will possess the kinetic energy, so that it will make the ball to move. Like that, you can take firing a bullet, flowing water, moving, hitting like throwing a ball. Windmills are rotating because of wind energy. So these all are actually, what is it everybody? Because of kinetic energy only. So every moving object in our surroundings, definitely they will possess the energy. That is energy we used to call it as, what is energy we used to say? Everybody?
Kinetic energy.
Kinetic energy. So due to virtue of its motion, please remember that. Virtue of its motion, the energy possessed by the body is called it as, what we used to call kinetic energy. So now in our today's class, we are going to discuss one of the most important equation. So what what important activity. So what that it will speak, we'll discuss it. So try to note that this you never find in your book and all, but you have to do it. So let's understand something from this. So now if you take here, suppose take a heavy ball and you can see that it will also, you can take first point. So activity, you can write it. So take one, I will say you understand the activity, then we'll make the conclusion. So I'm taking a heavy ball. What is this actually? A ball, heavy ball. Okay. Now you take even a wet bed of sand, it will be better. Like we can say, it's like, imagine you are in a like dangal. Dangal means you all know, you might be watched it. So there is a surrounding area which is not to hurt us when you fall it also. So take a sand area and you choose the heavy ball. So now drop the ball on the sand bed from the height about, let me take randomly, or 20 meters or 25 meters. So what will happen? I have taken a sand area, or you take a even wet sand, it is a better. You all can notice it. So all of you observe very carefully. So drop first this heavy stone, heavy ball from the 25 meters. Okay. So now as soon as the ball will come and hit, have you noticed that there is a depression will form in the sand? Am I right or wrong? Mari, understand, Mr. Mukesh, Lingesh?
Yes.
Yes. So, yes, Agalya, do you understand? As soon as the ball will come and hit, so as I told you, take wet sand, wet bed of sand. So, okay. So now as soon as the ball will come and hit, what will happen? It will form a depression. So what is that name? Call it as, all of you? Depression will forms. Okay. So now, if I take this ball into the next again, I will take this ball into the 50 meters and I dropped it. Now you tell me the size of this depression is same or it is more even deeper? Anybody?
More deeper.
More. Let it be. So I have dropped from the 25, you take it as 25 centimeters, 50 centimeters, then 1 meter, 1.5 meter. So like that I have dropped from 1 meter, then I have dropped from 1.5 meter in a different locations of bed. Now, you have to see the depressions are very clearly visible. That's why you don't drop in the same place, so that at different locations I have dropped from the 25 centimeters, from the 50 centimeters, from 1 meter, and as well as 1.5 meter. So totally 4 different times I have dropped. So today, if you're having a wet sand, as it is raining, you all can try this activity in your home, and you can make the real life conclusions also by measuring the depth. That is what depression we used to call it as. So now, mark the depressions to indicate the height from which the ball was dropped and compare their depth. That is what the depressions from the top position. So what is the depth of these depressions? So from everything, you can make it. You can give, this is a depression 1, depression 2, depression 3, and depression 4, which is created by various site which has been dropped, 1 meter and as well as 1.5 meter. Clear, everyone? All of you understanding? So then, mark the deepest impression. Which is the deepest impression in among all this? Anybody?
1.5 meters.
Deepest impression. So deepest impression are the depressions, if you notice it. So mark the deepest impression. Which one is the shallowest? Which one is the shallowest and why? You have to find it. And what causes the ball to make a deeper dent? So that is what is also make it. So let us, we'll take it, let D be the depth of the depression formed in, basically if I take a sandbag, wet sandbag. So whatever the height, if I drop, definitely I can see the impressions. That is what we used to say, means a sand will go little inside. That is what we used to call it as a depression. So now I'm taking a depth of the depression from the surface. I'm taking as a D, depth D. All of you write it. Now, and the object is falling from a certain height. So we don't know, formed in the wet sand bed, and force exerted by this on the sand bed. Let me take average force exerted by the sand in stopping this ball is F, and the ball which is falling mass is M. I'll have to remember what is this F. F is not the force exerted by this ball. F is what, everybody? F is the average force exerted by the sand. F is the average force exerted by sand for what? Anybody? Sand in what? In stopping what? In stopping the ball. Sir, why sir sand need to exert the force? Anybody can tell? For example, sand is not at all exerting force. What will happen? Does this ball will stop, or the ball will continuously pass through that? Anybody? Yes, please respond, guys. If suppose the sand is, or the surface is not exerting the force, what will happen? For example, there is a surface. Now I am dropping some stone. The surface is not resisting. It is not exerting any opposite. That's what force exerting to stop this body. So what will happen, everybody? The ball will pass through that. Am I right or wrong? Please respond, everyone.
Yes, sir.
Yes. For example, imagine the air. Air is like a sand. Now you see, now I drop the ball. Now, does the air is holding the ball, or the ball is passing through the air? Does the ball is holded by the atmosphere, or it is passing through the air? Everybody, please respond. Is the ball is passing through the air, or it is stopped by the air? That is what I'm asking.
Passing through
Passing through the air. Do you think that air is not exerting pressure on this object? Air is not exerting force on this object. Is it exerting or not? Even that force we used to call some force. It is a fluid. So fluid means they will exert what force? Definitely there is a frictional force due to the air. Am I right or wrong? But the frictional force exerted by the air is not sufficient to stop this object. That is why it will be driven through the air. But here the sand is exerting the force in opposite direction to stop this object of mass M. So average force exerted by the sand in stopping the ball is F. I have been taken. Now, use with the given data. So you all knows that it is freely falling. So that what is the initial velocity? Everybody? What is the initial velocity? All of you. Please respond.
0.
0. So before touching the ground, it will be having what? Final velocity. Maximum. Okay. And it is traveling a height of h. So based upon this, we can use the velocity of the ball before hitting the ground. We can calculate it by using which equation? Anybody? All of you? By using which equation? From the third equation, v square is equals to u square plus 2as, or it is falling from free fall equation. Gravitation chapter we have done. V square is equals to u square plus, what is that? 2gh. Now, as it is initial velocity 0, the final velocity before touching the ground, which is equals to, what is that, everybody? Root over 2gh. Now, here, the work done by the sand bed on the ball, the work done by the sand bed on the ball is equals to, for what purpose? To stop the ball, which is equals to kinetic energy. I am not having a formula. Formula already I know, but I am saying you. Kinetic energy of the ball just before hitting the ground. So that is what is before hitting the bed or ground. That is what we used to call it as a work done. Because we all studied that today's class. Energy possessed by the body is equals to what? Work done by the body. So whatever the work done by the sand bed on the ball to stop that ball, which is equals to the kinetic energy of the ball just before hitting the bed. So I will say work done is equals to force into displacement. So as we all know, which is equals to I forgot to teach you the formula. Later we'll go for the derivation. So kinetic energy formula is equals to half into m into v square. What is the formula for kinetic energy? Everybody?
Half into
Half
m.
mv square. V means not final velocity, velocity of the body. That is what you have to remember. Derivation I'll teach you. It's not a problem. So kinetic energy formula. What is the kinetic energy formula? Everybody?
Half mv square.
Half mv square. So that is what you have to remember. So now if you notice it here, so I will write it which is equals to half into m into v square. So if you take it here, so we all knows that half into m into v equals to what is the formula we got? Just now we got it. V is equals to what? Root over
2g.
2gh. So root over 2gh into whole square. So we all knows that square and root will get cancelled. So we'll get it half into m into 2gh. So 2 also will get cancelled, which is equals to force into displacement. So force into displacement is equals to mgh. Yes, everybody? Now we all knows that. Force means what? From Newton's second law. Newton's second law, force is equals to what? All of you. ma or mg. Am I right or wrong? Free fall. So I will say from this equation, force is equals to, we all can say that mg, then means which is equals to what? S is equals to what will happen, everybody? S is equals to h. Am I right? That is what. So I will say S is directly proportional to h. So what is this S here? Actually, we should not use S here. I will take it as a depression D. So that is what is better. So the force into depression, which is equals to work done by the sand, they are asking. So work done by the sand, I will consider as a force into, that is what, whatever the work done by the sand, the force applied by the sand and as well as the displacement of the ball which has been went. That is what we used to call it as a D. D means what, everybody? What is it called it as? Depression. Understand all of you? Clear, Agalya? So force into depression. D means again don't take distance. What is D means, everybody? Depression. Okay. So depression is equals to, you can see. So what is the relation? Depression and H. What is that? Both are directly proportional or inversely proportional to each other? Sanjay? Directly proportional to each other. That is what I want to say. So the depth of depression produced in the sand bed is directly proportional to the height from which the ball is dropped. Do you all understand, everybody, what I'm trying to say? All of you clear? So why I want to say you means, simply I cannot say you that if I drop from one point, you all said at the beginning, what you all said? So I have dropped from three different locations, 25 centimeter, 50 centimeter, 1 meter, and as well as from what height we have been dropped, everybody? 1.5 meter. So here the depression is producing this much, here the depression is this much, here the depression is this much, here the depression is this much in the sand bed. That is what is the depressions created by them. So simply I cannot say depression produced by the 1.5 is more bigger. Why? Because we have to prove it also mathematically. So we have been proved this depression. This depression, let me take it as a D4, and this depression is D3, and the depression created by this one, D2, and the depression created by this one is D1. So from this I can say, who is greater? Depression D1 is less than, D2 is less than, D3 is less than, D4, or the depression D4 is greater than, depression D3 is greater than, depression is D2 is greater than D1. Do you all understand, everybody? All of you? Please respond.
Yes.
So because at the fourth case, when the object is dropped from the 1.5 meters, it is the deepest because kinetic energy of the ball just before hitting the ground is in which case maximum? Everybody. Fourth case or fifth case, first case? Which case it is? The kinetic energy is maximum in which case, guys? In 1.5 meter 5. Understanding? 1.5 meter. Case number 4. Case 4 before hitting the ground. So that is what? The kinetic energy of the ball just before hitting the ground, which is in the case of 1.5 meters, is maximum. So that is why the energy of the ball just before hitting the ground, which is dropped from the 1.5 meter maximum, minimum in the case of 25 centimeter. So that is why here is the bigger or longer, deepest depression compared to in this. So that is what I want to say. So what is this here means? The every moving object will possess the energies, and if the height above from the ground is increases, and then if it is hitting, the impact on the ground will be more. That is what they will drive the more kinetic energy. Understanding? They will possess the more kinetic energy before hitting the ground. So why, sir, this discussion and all? Hammer case you take. So now one person, for example, hammer case also will take. So one person just lift a hammer into small distance. Let me take 25 centimeter. And here is the nail. Now here he raised the hammer up to here, and he has been again take. Another person is raised the hammer more distance, about 50 centimeter, and then he is coming and hitting the nail. Now you tell me who will possess the more kinetic energy? Yes, please. Who will possess the more kinetic energy? All of you? Who is driving the more kinetic energy? Case 1 or case 2? Let me take this is a B and this is A. Which case it is possessing more kinetic energy? Everybody? I'm asking you only, guys. So in which case kinetic energy is more? In this case, kinetic energy is EK1. In this case, kinetic energy is EK2. So who will possess the more kinetic energy before hitting the nail? EK2. Because the more distance the person is traveling, so that he will be filled more kinetic energy, so that more the deeper the nail will be go inside. So that is what you have to remember. So this is what is the kinetic energy, and I want to show the how the kinetic energy will be impacted on the ground when it is in the case of free fall. Then we'll discuss the derivations of kinetic energy in the tomorrow's class. I already taught you, but once again, and work energy theorem for tomorrow's class, and numericals related to kinetic energy and work energy theorem. So after that, we'll go with the potential energy. Only two energies you have